These are symbols of the panels. As I told you, we are ending the panel section. We are going to see, after these panel sections, we are going to see the regulator next in our next video. Now, today, let's jump to see. We have looked about the series connection, we have talked about the parallel connection, and we have talked about how the use of a series connection that to increase the voltages. Okay, now we again saw about the use of a parallel connection to increase the current, and voltages are constant. In series, to increase voltages and current was constant. In parallel, we increased the current and the voltages were constant. Now, today we are going to see, can we combine the series connection and the parallel connection? What is good in this combination? Because in series, we have the voltages. In parallel, we have the current. And in actual sense, we need all these things together for our system to work well, so that our TVs, lights, fridges, and other electronic components or gadgets can work for us. So we want to see, can we combine these things to improve the performance of the solar system? And this is our aim. As we calculated and we saw, even though you calculate, you use a series connection alone, your system will increase the power. Okay, even though you increase this solar system in series, the system the power will increase. Even though you connect them in parallel, still the power will increase. Okay, now today we are going to combine the series and the parallel connection. The same, the voltages, increase the voltage and increase the current, then you can put on our solar system and the system can work and the performance can be 100 efficiency. Now let us look at we combine, this is the symbol for solar panel. This is solar panel 1, solar panel 2, solar panel 3, solar panel 4, solar panel 5, solar panel 6. Any number you can use in solars or any number you can use on solar panel. It depends on the design of your system. We shall come on and we see how you can design, how many panels you want, you will need according to the client's appliances or gadgets he's going to be using at home. It will give you the number of panels. Okay, good enough. You have seen the series connection, we have seen the parallel connection. Now we want to combine those two things and we see, is our system going to work well? Are we going to enjoy the free sun? Remember, this solar topic is teaching you how to connect the solar panels, or we are going to see the whole system, solar panels, the regulators, then from the regulators, we see the battery. Then from the battery, we shall see the inverters. And these inverters will convert this power from the battery, the DC, and converts it into AC, alternative current, which your TVs, everything, the fan, the fridges will use. Okay, now let's jump into the combination, which is called a series parallel connection. Remember, we saw series connection, then we saw parallel connection. Now today we are going to see the series parallel connection. I'm going to enjoy this. The series parallel connection. The series parallel connection. Okay. Today we are looking series parallel connection. We are going to combine our panels in series, then in parallel, and our system will be really perfect. Never forget this, that it is very good and performance increases when we need the voltage and we need the current. Okay, in series there is voltages, in parallel there is the current. Now what if we combine the things together? And this is what we are going to see. How do we combine the connection of the series with the parallel, and we connect it to our system? Okay. Wow. Let us start with this solar panel size, this solar panel symbol. Yeah, this is the technical symbol for the solar panel. Okay. Let us make here to be our positive. Let me use the red. Let us state every panel has a negative point or terminal and a positive terminal. Okay. Now we have our positive terminal. Positive terminal. Positive terminal. Positive terminal. Positive terminal. Positive terminal. Okay. Now, each panel has a positive terminal. The same way, each panel has a negative terminal, which is going to be, let us put it inside. Let me put these ones inside. Okay, so that we can see the thing well. Positive terminal, positive terminal, positive terminal, positive terminal, positive terminal, positive terminal. Now let's check. We need the negative terminal because each panel has two terminals, a positive and a negative, which you connect to the battery or to the regulator before you go to the battery. You don't need to miss the regulator part, which you are going to see. Now let us put here our negative, 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 negative. Okay, now we have two terminals. Each solar has two terminals. The solar has the positive terminal and the negative terminal. Okay? As we are going to connect these things both in series first, then we connect them in parallel. And we connect this and we shall get the two terminals, the positive and the negative. Okay? Let us see. How do you connect in series parallel connection? Okay, what is the science behind? The science behind is we want to increase the voltages. That is the series connection, and we want to have much current to power our battery or to charge our battery. Okay, do you know where we need current? Do you know the battery that it has? Let's say the battery has 70 Ah, A and H. Okay, like this. Most batteries are measured in ampere hours. Let's try to say 70 Ah. I think you have seen this on a lot of on batteries. Okay, this 70 Ah, A is the current, which means we need the current. That is the parallel connection, and the hours, which means how many hours. Now, it means current. We need current more than the voltages here. But you cannot find current when there is no something, the force which pushes the current, which is the voltages. Okay? Volt is the pressure which pushes current. So, current cannot move alone. It moves with the voltages. So, it means if the batteries are measured in ampere hours, there is voltages inside here, and mostly we need the current. That's why we have the parallel connection, and the series connection will bring the voltages, and current will move to our batteries. That's why we need the series parallel connection. The series we need the voltages, the parallel we need the current to charge our battery. Okay, for how many hours? That's where this hour come from. For how many hours does our battery going to serve the appliances in our house? Okay, let's say our TV we shall watch our TV around 3 hours. the security bulb will light for 6 hours. The fridge will work for 2 hours or 1 hour. Now this hour comes in and the battery will serve your system. After knowing the current from the panel, then you know the current which will be used by the appliances at home. This is for the batteries, but we have not yet gone to the batteries. That's after the regulators, we shall see the batteries. That's why I told you, watch step by step, video per video. You will learn more in solar. Don't miss any video so that you're perfect in solar installations and repair. Though, now, let's come back to our point today, the serial connection. Let us connect our panels in series, okay? Without wasting time, we can connect in series. We say negative, positive, negative, positive, okay? Let us see this. Negative, positive, negative, positive. We have our negative, our positive and negative. It means we shall connect this positive terminal to this negative terminal. Okay? Or let us connect them because here it is near this panel. We can connect this terminal, positive terminal and negative terminal. Okay? We have connected this panel, a negative terminal with the positive terminal, and that is a series connection. Let us also connect these two panels into a series connection. We get them negative, we connect them to the positive. That is a series connection. The same thing here, negative to the positive, that is a series connection. Now, these two panels are connected in series. These ones are connected in series. These ones are connected in series. A positive, we have the positive out and a negative out. The positive, negative are combined, and that is the series connection. The same applies to these panels, okay? Now, how can we connect these panels in parallel? Okay? Can we connect these panels all in parallel? Let us say our system, we wanted a, let me say, our system is 100 watts. 100. Okay. Let's do like this. All these panels are 100 watts. 100 watt. 100 watts. 100 watts. 100 watts. 100 watts. Okay? We know very well that this panel, if I connect them in series, they add up. The power adds up. If they are having the same power rating, the power rating is the wattage. These panels, the power increases. So if we have 100 in series and this panel we have 200, if you measure here and this negative terminal, we shall have, okay, let us say, if you measure here and a negative and a positive, okay, this is positive, this is negative. If you get your meter, if you get your meter like this, this is your meter, okay? You see it? This will be the meter. as a electrician or a technician or a solar installer, you have to have this. Okay, if you want to measure, if you want to measure the voltages, okay, you put, because if this panel is 20 volts and this panel is 20 volts, they are connected in series, okay, connected in negative and a positive in series. If it is 20 in series, we said the voltages adds on, and you will put, if it is 20 and 20, that is 40 volts. Okay, now to measure the 40 volts, you don't put your meter. Okay, you see, you don't put your meter on 20 volts. Okay, you don't put your meter on a 20 volts. Put your meter the higher than the total voltages which we're expecting. We expect 20 plus 20, 40. Then this meter will have a 12 volts, 20 volts, 200 volts, okay, then 600 volts. This is DC. You measure it in DC, okay, not AC, okay. When you're measuring your power from the panels, measure them in DC using your multimeter. Don't measure in AC, okay. Only the machine which converts DC to AC is the inverter, where we shall go after. Now, put your probe. 200 is here, okay. Put your probe on 200, okay. Now leave, it will count 0.00 because it has not received any value. Now the solar panels are on the roof, meaning they have produced power. When the sun hits the solar panel, we said solar panel automatically they produce electricity in DC power, which electricity is converted. They convert sunlight into electricity by the effect of electro or photovoltaic. Okay, now measure, get your positive terminal, put it here, and you get your, no, this is a negative terminal, and then you get your positive terminal, you put here, and the reading will come here, that 40 volts, okay. The reading will come as 40 volts. Now, since we have connected this into series, also the same thing happens here. 40 volts, since our panel is 20 volts, okay? And our watts will increase. If this is 100 watt, this is 100 watt in series, the wattage will increase, will add on, both in parallel and series power add-on, and we shall have a 200 watts. Since we may be designing a system which needs a 200, we need 200 according to our batteries, okay. According to the ampere hours, we may be needing 200, but 200 we need the current and the voltages when they are very good, strong, and enough for our system to run. That's why we are connecting in series and parallel connection. Because we have seen that in series, when one panel has a shade, it affects this panel, okay? Because this output will be affected. Or this panel gets a shade, this negative terminal will be affected, and this system will have no output, okay. And yet when we connect them in series, even though any panel is shaded or an effect on any panel, the system will not have any effect. That's why parallel connection is a bit of good system to connect your solar panels. Now let us join them in parallel. Since we have finished joining them in series, let us try to join them in parallel. Always start with negative. Always start with negative when you're connecting solar panels. In electricity, always, or in electrical, always start with a neutral. Or you must first start with the earth, then connect the neutral. Then live comes later. Live is the red pan, the red cable. Now let's take this to be the red cable, the live part, and this negative to be the neutral. Okay, because when we are entering the electrical bit or the electrical lessons, and we shall have these things, because you can't do this without knowing electrical. You must wire the house. Okay, you must know that positive, neutral, because when the inverter gives out AC, you must be knowing the neutral and the live. Now let us connect this in parallel. We have connected them in series. Okay. Then let us connect them in parallel. In parallel, we shall get this negative. We said in parallel connection, negative terminals, you combine them together. How? Like this. Let's combine this here. Okay. This negative and this negative are at the same terminal. Then we combine also this negative. Let it come. Negative are on this terminal. This is a parallel connection. If this panel gets a fault, it will not affect this panel because this negative will pass. When this panel gets a fault, its negative will die, and these two panels will still work as usual. Meaning, in parallel connection, any panel gets fault, it doesn't affect the system. But in series connection, any panel which gets fault, it affects the system. Okay? Let us also connect these. Let us also connect what? The positive in parallel. Because we have seen the series connection done. Now we are connecting them in parallel. Let's connect. Let's drive our cable to this panel. This terminal is here. They have the same point. This point is the same as here. This point is the same as here. The same way we connect them in parallel. Okay. This point here is the same as here. Okay. This point is the same. This point is the same here. This point is the same here. And this is series parallel connection. Series parallel connection. Series parallel connection. Okay. This is the how we connect solar panels in a series parallel connection. And here we shall be having our output. Okay. And this output will be enough for our system to work in our homes. And if you connect like this, when you have more than 2 panels, 4, 6, these are 6 panels. Even though you have 4 panels, please try to do this connection. And you can, if you remove this in parallel, you see, the things are in series parallel. Even though we rub off this, we try to see, and we see this. If you connect system in parallel, it is very easy to add on another system. If you get another panel like this, you can still do the same thing like this. This is another panel. The client got some more money. He wants to upgrade the system. Then the system needs to add some panels. Okay? And this is negative. He bought another panels. Then a technician will come and still connect this point. The same way you connect them, you make a series connection, then you connect in parallel. The same thing, this terminal here is the same as this terminal. Okay? If you want to remove this, the same thing, only this will work. Series parallel connection. Okay? And our system will be okay. Note, because we are ending the series, the panel connections. I think you have now the knowledge about the panels, about the series connection, about the parallel connection, about what if I get a small panel with small watts and a big panel with big wattage. What should I do? We saw that if you connect those things in parallel is good, not in series. Okay? Because voltages will move from high points to low points. Meaning, if you get a 10 volt panel and a 100 volt panel, or a 24 or 20 volt panel, this 20 volt panel will push its voltages into a small panel and it will affect it. That's why in series, that's why it's advisable we put them in parallel, because parallel, each panel stands independently. Even though the other panel is affected, the system is not affected. Okay? And this is how the formula or the connection is done, a series parallel connection. We are going to go in the regulators. After connecting your solar panels, where should you connect these two terminals, a negative terminal and a positive terminal? The first thing to do is you put them, you need a control, because once you install the things, you need to first put a control before you connect a regulator. Which control is the circuit breaker. Put always a circuit breaker here before before the cables go to the regulator. Okay? Let us try to put a circuit breaker. From our panels, now we are entering the house. We have entered the house. We are now out from the roof. We are in the house. Now, this is our circuit breaker. Circuit breaker will be having one way with a switch in the middle. Okay? Let me make it a bit understandable. Okay? These are screws. I don't know if you are seeing. You will bring your negative terminal, as we said. You first connect a negative terminal here. You screw it. This is negative side. Then you bring your positive side also. Your positive side here. You screw it. Okay? And this is your positive output. This is input, this is output. A circuit breaker to control the flow of current, of power, of voltages from the panels. Okay? These panels, after installing them, they will they will produce power automatic. Whereby this power, it needs us, before we control it, may shock us. Okay? You may install 10 panels, and the moment this cable hangs around the house, it is having power, high voltages, which are DC, high currents. Okay? Because we said in parallel we shall need big cables, so that anything dealing with current is so essential in the system. Okay? It is the one which shocks. It is the voltage is pushed, then current pass through you, then you get electric shocks. Now we need to put this controller, a circuit breaker. okay, before we start supplying the solar panel into the system. We first put a circuit breaker to control and switch off. Okay, switch off, then you can start do the wiring in the house. And today we are ending the solar panel lessons. Okay, now we are at the circuit breaker. We are going into the regulator. Here, this point here, it is taking us to the regulator, or some people call it charge controller. This point, this is where we're going to connect our charge controller or a charge regulator. And I hope the next lessons we are starting our regulator or charge controllers. And we see, after finishing the panel installation, you install your circuit breaker to control the power. Then now start off, before you connect your regulator, first leave your power into the circuit breaker and switch off the circuit breaker. Yes, this is the circuit breaker. And your power from the panel will be here, waiting to be connected to the regulator. Okay, and don't wire any installation without putting a regulator, please. Okay, the regulator controls the charging and discharging, as we are going to see the use of the regulator, why regulator is needed. Why do we need a regulator in the system? Because we say a regulator is the heart of the solar system, as we are going to see in the next chapter. After here, we wait to install the regulator. Before you install the regulator, the inverter, the battery, then you start use our system. Thank you for watching. If you like, subscribe, like, comment, and share this video for more information or the tips, electrical tips, solar tips, and both how we shall see the electronics, electrical and solar in this channel, The Physics Mindset. Thank you for watching. See you in the next video.